Good morning, everybody. I would like to take this opportunity today to share with you these intense and very much challenging 2 years of my career within the Transit Consortium, meant to me, but from a personal perspective. So if you allow me to do so, I will go briefly over some scientific details that I was allowed to disclose, and then try to get to a different side of this experience. My name is Matilde Duran, and 2 years ago, I joined the Transit in this amazing family in the lab of Maria Jose. And as a postdoc in the Transit, my role was to understand the barrier and understand the carrier. But with the specific goal of coming up with a carrier that could give response to several requisites. The starting ones were that it had to be produced with materials and methodologies that were both biocompatible and scalable. And it's incredible how much that can narrow your options from what you know and what is out there in the literature. But also, apart from that, it had to comply with the requisites of an oral drug delivery form. And most important of all, and the hardest part, is that it had to work. So to give a reply to all of these requisites, we based our strategy on the first hand on protein-metal interactions naturally occurring within the body. And we combined that with ionic and hydrophobic interactions of stabilizers, between these stabilizers with these particles. Thanks to that, we got to this most representative result. And I have to say that without the advice of Professor Bruno Sarmento, that is here with us today, this result would have not been possible. And here you can see the result from an in vivo study with animals displaying the disease of interest. And you can see the difference between the formulation in blue and just the protein encapsulated, but this thing alone. And you can see that there is a high marked difference between those parameters and in terms of the reference parameters. Thanks to that, as an output, we have 1 patent in preparation and 2 publications as well, a contribution to an already submitted paper. And as a future steps, my career will go to the side of entrepreneurship with an internship in a consultative firm. And then we will also try to set up our entrepreneurship project called SADIA, Scientific Advisors, that was awarded the Woman Entrepreneur Award from the Santander Bank and the Ernst & Young Foundation. And here comes the part that was the most difficult for me with preparing those slides. And when I thought about what I had learned, I could look at those lab notebooks from these 2 years, and it was very curious that I could open any of those lab notebooks at whatever page, and I can tell you precisely how I was feeling that day when I was performing that experiment. And it's hard because 9 times out of 10, those were feelings of frustration and disappointment because something was not working out. But each of those moments taught me a personal lesson, which is what I would like to share with you today. And in turn, I will try to ask you a few favors. Well, the first thing that I learned is how far it can be what we can publish from what can be turned into a product candidate. And I think that for a young scientist, as we are, this is very much disappointing. But now we know about it, and I think that in our future work, we'll address our experiments being aware of this. On the second step, I have learned that if you want to have an effective collaboration, your work doesn't end when you have a sample, you prepare it and you ship it, not at all. You have to be there, also there. You have to communicate. You have to understand what the other person is doing and understand that those people, those partners have spent crazy hours also setting the surgery, looking for the right side of a catheter, setting a cell monologer. And if you want it to mean something, then you have to be there and get the best out of you there and communicate. On a more personal side, I have learned that we all have to be self-confident with our ideas, but we also need to be open-minded with the ideas of others. I am sure that all of you, at some stage of your career, you have had an intuition about the work that you were developing, but maybe some people were telling you, I wouldn't spend time on that, I don't think that's going to work, but you still believed, and you went ahead, and you proved that you were right. And you were like, I knew it. And that feeling that you're useful in science, that feeling is awesome, and we love it, and it's one of the best parts of science. But then there is this other side of a situation in which you are the one that does not believe in the ideas of others. And I cannot tell you how many times in these 2 years I was told to try something. And maybe I was thinking, there's no way that's going to be the solution to my problem. I'll do it because I have to, but just to prove that it doesn't work. And then it worked, And it got me out of a situation in which I was stuck. It was for my own good. So I have learned that this is how science works. This is how a team works. You need to be very self-confident with your intuitions, but you also have to be very open-minded with the ideas of your colleagues and your advisors. Also very personal, this part. I am still learning how to counterbalance the ups and downs moments of your research. And with a down moment, I'm referring to that hyper-crisis moment when you're about to hand in your thesis manuscript, when you have an in vivo, when you're finishing an internship, and you're super stressed, and then suddenly, out of nowhere comes this bad result. You know why? You don't know why. And it kind of destroys your whole idea, everything that you have been working from the past year, the past months, you're stuck, you don't know why, and you cannot get the way out of it. And here's the first favor I'm going to ask of you. I would like you to picture in your mind, when you are in that moment, who is the person that you call? Who is the person that you speak to, that you Skype? Who is that person there that even though they know nothing about science and they don't understand why you go to the lab on a weekend or on holidays, they tell you, I trust you. You always find the solution. I trust you. And it's true, because the next day, you're relaxed, you're calmer, you see everything from the big picture, and you realize of any significant detail from yesterday that today it means it all and puts everything back into place. So the second favor I'm asking of you, mostly for the younger people, is when you feel that you're approaching that down moment, stop, keep calm, take a step back, relax. It's not worth it. And remember, you will see the solution tomorrow. And for the up moment, to everybody, please, that person that you have in your mind right now, tell them that you appreciate so much that they are there to support you, because we never think so as much as we should. And that comes to the last but not least thing that I have learned from here, which is the support, not only from those people, but mostly from the people in your lab. Those colleagues, friends, that they spend so much time with you, that they get to know you so well that just with a glance they can see in your face if you're having a bad moment or a good moment. And even though they have their own problems, they are super stressed, that they own hyper crisis, own projects, they still scratch some minutes of your time to help you and to support you and to cheer you up. And that is priceless. So this is the third favor that I'm asking of you, which is please make sure that you're surrounded by that people and that you take care of them as much as they are taking care of you. Because in 5 years, there will be another most important project, most important grant, most important deadline, and you will not remember about what you presented here. You will remember about those people, so please take care of them. And last thing, if you ever find anybody that doesn't believe in you, take care, because many times it is yourself doubting yourself. Be aware that you are where you are because you deserve it, because you earn it, and it's not by luck. So the next time that you doubt about yourself, or anybody doubt about yourself, I would like you to stay calm, not get into that, smile, because deep down you know that you can do it, and then go for it and let people watch you do it. Thank you so much for your attention. That's all. If you have any questions.
Great. Power of positive thinking. Any comments in the audience? So I think one of the things you said was very interesting in that most of our experiments fail, and that you have to be able to deal with that. And that's part of the process of developing.
Exactly.
Somebody had a hand up. Justin.
Yeah, you showed some data that was your nanocarrier versus the protein reference, and I wasn't sure what the assay was or what you were measuring.
It's an animal model displaying the disease. The formulation was administered to a group of animals orally, intestinally, and then the protein alone, without any other excipient, was administered also to the same model in a control group. And this is what we measured. I don't know how much I can say about this. This is a diabetic model, and in the intestinal administration of the formulation containing the protein, and this is the control, which is the protein alone.
Do you have any other controls, or are you considering any other controls moving forward? Relative of how this is doing compared to other?
Yeah, the best thing to do would be also to have a blank control of the formulation, and also if we had some reference positive control parameter, which I think is something that we have been looking for, but we unfortunately didn't have. And there is a specific with this formulation that because it is based on mostly the interaction of the protein with a metal, there is not a blank carrier for it. So either you have the protein included or you don't really have a formulation. We could try, of course, a solution of the rest of the excipients as a control, but it was limited the number of groups that we can handle with that type of administration at the moment. Sí. Yes.
Okay, one last question, Patrick.
The metal and another protein. Yeah, it should be with a protein that had similar characteristics, and also I think that a good way, interesting way to go in the future is to look for this type of interaction with another protein and another metal, but that is based on what happens in the body. Many proteins have interactions with metals within the body as a storage material, as part of the reaction or the synthesis of the protein. So I think that would be, and actually something that we will look forward to do in the lab in the next months.
Okay, thank you very much. We have to move on.
How reproducible can you make your system? Is the size stable?
The system, yes, I think that that's one of the strongest points of the system. We have been able to make it reproducible and also to scale it up. We have done batches of 2 milliliters, 20 milliliters, and 200 milliliters, and also with freeze drying it. And we have been able to maintain the properties during the scale up and also after the freeze drying process.
Okay, thank you very much.
Thank you.